Welcome to a quick tutorial on how to enhance your projection mapping workflow with the help of Vertex's 3D calibration markers. While this 3D project item is an accurate representation of my real-world projection target, in Vertex it's only a geometry file that would be rendered invisible without a texture such as our UV test pattern, which I'm gonna drag on top of my object's clip container as an auxiliary content for our projection mapping. By default, the render editor is set to a 2D mode. Changing it to 3D up here will just enable the editor's helpers, like the 3D grid, to actually change the canvases and surfaces from 2D to 3D mode, including the near and far values of the rendering Z positions. Please switch to 3D via the render editor's context menu. And now our display geometry makes much more sense. Next, inspect the surface connected to your projector's output and go to the Viewpoint tab and Calibration Settings. Disable Live Calibration Update for now, as we're going to add multiple markers that are not even remotely positioned, so it would not reproduce a pleasurable result with Live Calibration Update on. The Calibration Markers category has got a button to add a marker. If we want to grab it in the render editor, we need to switch the edit selection to markers. Hold down the Alt key and use your mouse wheel to shift the camera angle in the render editor. Select the new marker in the center, and while holding down the Control key, clicking on a corner of your object will snap the marker to the nearest possible vertex in that region. Repeat this process one by one until a minimum of 6 non-coplanar points is achieved, i.e. you need 6 markers at least with different levels of depth and distance. Next, switch the render editor to Systems Output View and select the assigned output to your projector. After you've made sure that the editing level of markers is enabled, go back and select the surface to display our markers. All 3D markers are still set to 0, 0 top left, so you need to reset the 2D coordinates, thus aligning the calibration markers from the 2D projection space with your object's non-coplanar points. Now I've set up a camera to show you the real-world projection as we continue. One by one, you can grab each marker in the render editor with your mouse and drag them to the corresponding position on your object's corners in the real world. While in this mode, Vertex displays little targets for the markers in your projection. Once you've aligned them roughly, click on the Calibrate button in the Surface Calibration Marker settings and let Vertex align the surface around your 3D geometry. At this point, you might need a second pair of eyes on stage, guiding your pixel-shifting hands. Now we should be safe going back to the calibration settings and enabling Live Calibration Update again, and fine-tune the calibration markers with pixel accuracy using your arrow keys. Also, you may check your level of accuracy with the help of the Reprojection Precision property. The lower the number, the higher your precision. What also might be helpful in this process is reducing your clip's opacity for a better visibility of your markers. Let me leave you with a pro tip when using projectors with wide-angle lenses. The lens distortion that may occur can be compensated with the help of geometry modifiers. Just add an FFD from the library using Vertex's regular warping workflow. Now, once you're all set, turn up your clip's opacity again and you're good to go. If you have any questions or suggestions regarding this workflow, please write us to support@ioversal.com. Thanks for watching. Bye-bye.